All right, today we're going to dive into a really powerful technique that can seriously boost your database performance. It's called vertical partitioning, and it's one of those super simple ideas that can make a huge difference in how your system handles data. So let's get right into it.
Okay, so picture this. You're running a massive online store, right? And your customer database is just huge. It's got tons of columns, name, email, shipping address, and maybe even stuff you barely ever look at, like old survey responses or personal preferences. Now, what happens when your system just needs to grab a customer's name? Well, it has to dig through all that other junk, all that extra baggage. And yeah, that's going to slow everything way, way down.
So before we even get to the solution, let's really nail down what the problem is. Why is this even a thing we need to think about? Well, it's a super common performance bottleneck, and we can call it the wide table problem. And here it is. You can see it right here. This is the problem in action. You've got this one single customer table with everything crammed into it. So when you run a super simple query like, hey, just give me this customer's email, the database still has to load this entire massive wide row. It's grabbing columns it doesn't even need. That's just a crazy waste of resources.
All right, so how do we fix this? How do we get out of this mess? The solution is actually pretty elegant, and it's all about simplicity. We just need to stop thinking about the table as one giant single block of data and start splitting up the columns.
And that brings us to the official term for this, vertical partitioning. It's exactly what it sounds like. You're literally slicing a table vertically. You take one big wide table and you break it up into a few smaller, much thinner tables. And each of those new tables just holds a specific group of columns from the original.
Now hang on, because it's really easy to get this confused with its cousin, horizontal partitioning. Let's clear this up right now. So remember, vertical partitioning splits by columns. Think vertical slices. This is what you use when your queries are constantly asking for just a few columns from a really wide table. Horizontal partitioning, that's totally different. It splits by rows. Think of it like putting all your North American customers in one table and all your European customers in another. You use that when you have a bajillion rows and you need to split up the load. Two different tools, two totally different problems. Got it? Okay, so the whole secret sauce behind vertical partitioning, the key idea is this. You figure out what data gets used all the time and what data just sits there collecting dust. You separate the frequently accessed, or hot, data from the rarely used, or cold, data. Let's make this real. Here's what it looks like in practice. This is our first new table, Customer Basic. You can see it only has the hot stuff, the ID, name, email, the things you need for logging in, sending out newsletters, the day-to-day operations. This table is small, it's lean, and because of that, it is incredibly fast to query. And then, here's the other half, the customer details table. This is where we dump all that cold data we talked about, the phone number, the full address, those user preferences. Now look closely. Both tables have the customer ID. That is the all-important link that lets us join them back together. But, and this is the key, only when we absolutely have to. Okay, so we've done all this work, right? We've split our table apart. What's the payoff? Why bother? Well, let's get to the really exciting part, the performance boost. Oh, the benefits are huge. For starters, queries get way, way faster because they're scanning so much less data. That means less I/O overhead on your disk, which is always a win. Your cache efficiency goes through the roof because that little hot table can probably fit right into memory. And what does all this mean? The whole system just becomes more scalable and way easier to manage. And if you need to see it to believe it, check this out. This chart says it all. On the left, that's the response time on our old, bloated table. And on the right, that's the same query running on our new, lean, hot table. I mean, look at that difference. It's not just a tiny improvement. This is a total game changer. Okay, this all sounds great in theory, but you're probably wondering, how do I actually do this? So let's walk through a practical, step-by-step guide. It really just boils down to 4 main steps. Step 1, you've got to play detective. Analyze your system's queries and figure out which columns are always being used together. Step 2, you group them logically. This is where you create your hot and cold piles. Third, you go ahead and create those new separate tables. And finally, and this is absolutely crucial, step 4, you have to update your application's logic so it knows to read from and write to the correct new tables. All right, I gotta be real with you. This isn't some magic silver bullet.
Like any really powerful technique, it comes with some trade-offs. So to give you the full picture, we need to talk about the challenges and, more importantly, the best practices for getting it right.
First off, you need to be aware of the potential downsides. If you often need data from both the hot and cold tables at the same time, your queries will have to do a join. That can add complexity and, yeah, it could even cancel out some of the performance wins. You also have to think about keeping data consistent across multiple tables. An update to one might need a transaction across both, which can be tricky. And like we just said, you have to change your application code. And let's be honest, that can be a pretty big job.
But don't worry, you can totally handle these challenges if you follow a few best practices. Number 1, don't guess. Please, don't guess. Use monitoring tools, look at your actual query patterns, and make data-driven decisions. Second, start small. You don't have to boil the ocean here. Just pick your single worst, most problematic table and start there. See what happens. Also, a great pro tip is to use database views. They can hide the complexity from your application, which is a neat trick. And of course, the golden rule of, well, everything in tech: test, test, and test again. Test it all thoroughly before you even think about deploying to production.
So what's the big takeaway here? It's that by being smart and separating your hot data from your cold data, you can unlock some truly massive performance gains. And that leaves me with just one final question for you to think about. Go look at your own systems, your own databases, and ask yourself, what cold data is slowing your system down right now? Thanks for tuning in.